Hello friends, welcome back to my channel. So today we are going to learn a technique to solve the problems like the problem displayed here. Now this technique is known as transferring the segments technique. The problem you see on the whiteboard right here can be solved using three ways. The first way is as evident, uh, Ptolemy's theorem. The second one is trigonometry. But we are going to learn today a technique, a very odd technique, a very different technique used to prove this type of problems. It is known by the name of transferring the segments. So let me write it. Transferring the segments. The segments. So this is the name of the technique. Now this technique is used when suppose we like conditions like this. When two sides are given and their sum or difference has to be displayed as some other side. Likewise, like let me give you an intuition how that technique works. So let's assume we have a line. Now in this line, let's suppose there were two distinct lines. This yeah wait this one, these two lines, let's name them A, B, C and D. So there are two line segments AB and CD. Now we have to prove that K are the bigger one. Now suppose we are given to prove that AB plus CD equals KR. Now how we can go about it? So there's a technique, we can transfer both of these line segments, the CD and the AB, to this line segment and prove that they cover equal area. What I mean is, let's transfer AB to KR. I mean, let's mark some O on KR such that KO equals AB. Now, instead of proving that AB plus CD is equal to KR, this problem is now reduced to proving OR equals CD. I hope you're understanding it. Now, this is the technique we are going to use to solve the problems like this. These occur frequently in Olympiads, so it's a great thing to know about them. So let's start. Now, as given in the question, let's draw a quadrilateral. Uh, Wait, I guess yes. So yeah, this is the first side of the quadrilateral. This is the second side. Let this be the third side, and let this be the fourth side. Now, as written, if we mark these angles to be A, B, C, and D respectively, this angle is given to be equal to 60 degree, and this angle is given to be equal to 120 degree. Now, as known from the property of quadrilaterals, it is clear that this quadrilateral is a cyclic quadrilateral because the opposite angles sum up to 180 degree. So let's draw this quadrilateral in a circle so that some properties of circle might help us in proving the result. So here is a circle, is our desired circle. Let me draw a bigger circle. Yeah, I think this should be okay. So this is the first side. This is the second side. This is the third side. And this is the last side. Now let's name the angles A, B, C, and D respectively. Now this angle is given to be 60 degree. So I guess we should name it outside so that this doesn't disturb our constructions. this angle is presumed to be 120 degree. Now we are given that AB equals AD, so these two sides equal each other. Now we got to prove BC plus DC equals AC. As I showed you previously, the concept of transferring the segments. Now I want you all, if you know, if you, I think till now you have got the idea of transferring the segments. I want you all to pause this video and give this problem a try. And when you're done, keep watching for the solution. Now, what we will do is let's join AC. That's what to be proven in the end. So let's join AC. Oh, I mistakenly typed spelling of transferring as TRS. Whatsoever be, we joined AC. Now we have to prove that the sum of this length BC and this length CD equals this length AC. Now, how the transferring works. So let's assume a point K to be here such that AK equals BC. AK equals BC. So now let's join K to D. Now, if you can see clearly, AK equals BC. So we are left to prove that KC equals CD. Now this, the proving BC plus DC equals AC is equivalent to proving KC equals CD, because once KC is proved to be CD, AK was pre-assumed to be BC, so AC is total AK plus KC, which in turn equals BC plus CD. I hope you are understanding what I'm telling. So let's start how to prove that. Now, first of all, we are going to do a construction like this, join BD. So from the basic theorems, we assumed, now we are going to use congruency to prove that. Now BC was equal to AK. We assume that too. Since this triangle ABD is an equilateral triangle, as you can see, if you can't, let me show you. Angle BAD is 60 degree and these two sides are equal. So these two angles necessarily be 60 degree. There's no other choice. Sorry. Yeah. So all these three sides equal each other. Oh, yes. All these three sides equal each other. These three. Don't be confused by the lines I made. So in triangle BCD and triangle AKD, BD equals AD, as they are sides of equilateral triangle, and BC equals AK. We assume that. I hope you remember it here. If you can't see, we assume that. Now, uh, if we consider the segment CD, the segment of the circle CD subtends an angle here, the same angle at this place too. If you know that a chord subtends equal angles on the circumference of the circle, on the opposite side of the diameter, I mean. So we can clearly write angle BCD. Oh, sorry, oh, my mistake. Angle, wait, let me rub this off. So yeah, angle CBD equals angle DAC, DAK, yes, so that the triangles become congruent. Now this is SAS. By SAS congruency criterion, triangle ABCD KD is congruent to triangle BCD. So from by CPCT, we can clearly see KD equals CD. So these two sides, let me mark them with a different color. These two sides are equal. Now, one thing more should be noticed here. What that is, if we consider the chord AD, I hope you can see this chord right here, AD. Then this the angle subtended here equals the angle subtended here, because the same chords subtends angles at two different places, and those angles are equal. So this angle is also equal to 60 degree. Now since this is 60 and these two sides are equal, this must this must be 60 degree, and we are left with one angle that should also be 60 degree. No other option. So, yeah, this is also 60 degree. So all the three sides are equal. That means the triangle KCD is equilateral. So clearly KC equals CD, and that's what we required to prove for the main result. Now we can reverse some steps, like we can write AK plus KC equals AD, as is evident from so I'm sorry, mistake, equals AC. But AK equals BC here, and KC equals CD. So from the left hand side of this identity, we have proved our result. Now this was a amazing technique of transferring the segments. I hope you enjoyed to learn it. I hope you will use this in further problems. Now I was unable to find some other problems of the same type. So if you have got some reference or some, if you know about some competition where this type of problems were displayed, I mean to prove like this, where we can easily sense the use of this transferring segment techniques, please do comment below. Thank you for watching. I hope you enjoyed the video.